Oh, what's up? This is gonna be a skill practice 37. Let's get right into it. Yeah. Oh, sorry. Okay, number one. In a reaction, 24.9 liters of nitrogen reacts with excess H2 to produce NH3. How many liters of NH3 were produced? How many grams of NH3 was this? The pressure in the lab was 97.8 kilopascals, and temperature was 23.7. Okay, so a lot of information here. Let's go to the first question. How many grams of NH3 was this? So grams of NH3. So we're given we're given liters, and we're going to go to grams. Oh, well, actually, that's first. Actually, just write out the chemical formula. So N2 reacts with H2 to produce NH3. And we notice that this chemical equation is unbalanced, so let's balance this. There's two N's on this side, only one on this side, so we add two. There's six H's on here, only two, so these are three. All right, so balanced. So gas stoichiometry is the just the tables type of thing. Um, from actually, hold on. The first question we should be answering is how many liters of NH3 are produced? So basically, we have 24.9 liters of nitrogen, and we want to find out the liters of NH3, right? So we're going from liters to liters. And so going from liters to liters, it's just volume to volume, right? And when we go from volume to volume, we can just use the mole ratio. 24.9 liters of N2. And then we want liters of NH3, right? And so using the mole ratio, there are 1 mole of N2 to 2 moles of NH3, right? Because this is all proportional. So 24.9 times 2 is going to be 49.8 liters of NH3. All right. So the second question asks how many grams of NH3 this is. So grams, we have liters and we're going to go to grams. Which formula would we be using? Would it be combined gas law? Would it be Pivner? Would it be gas? Would it be tables, the gas lake? Now we're gonna be using a Pivner because Pivner has not only has grams, right, for the moles, the N is moles, it also has liters in the volume. So we're gonna be using Pivner. So Pivner is plugging chugging. The pressure is 97.8. The volume is 49.8. The N moles is what we're trying to find. And then the R constant is 8.314. And then the temperature is going to be 23.7. Did you catch my mistake? Because I was wondering if you were paying attention, because I actually was kind of test you to see if you would understand. You would catch it because you don't actually use 23.7 Celsius. You need to be using Kelvin. 290, and so 23.7 Celsius to Kelvin, you just add 273.15. That's going to give you 296.85. You plug in chug, N is going to be 1.97 moles. And then you're not done yet because you're going to go from moles to grams. So 1.97 moles of NH3. Right. In the end, you want grams of NH3. So set up a table. It's what you want over what you have. Right. So and then what you want is grams, what you have is moles. Grams or moles, this is NH3. So this is grams or moles, this is molar mass. The molar mass of NH3, let's calculate this real quick. Here on the table. So N is going to be 14, I think. Yeah, 14. 14 plus H and H3. So there's going to be 3 hydrogens. So 1.008 times 3. The molar mass of NH3 is 17.024. And then this will give you 1.97 times, so maybe 33.5. Cool. Number 2, if 22.5 liters of oxygen reacted with excess hydrogen, how many liters of water vapor, gaseous water could be reduced? All right, so let's write out the chemical formula. So oxygen, O2, reacts with hydrogen, H2, to make H2O, like gaseous water. Um, so let's balance it first. This will be 2, this will be 2. Okay. And so in the question, you have 22.5 liters of oxygen, and we want to get liters of H2O. So we have liters of O2, we want to get to liters of H2O. And so this is just volume to volume. This is the exact same concept in question 1 in the first part of question 1. So it's going to be 22.5 liters of O2. And then we can just simply use the mole ratio of that's going to be moles of H2O over moles of O2. What do you want or what you have? You want H2O, that's going to be 2 moles of H2O and then 1 mole of O2. So 22.5 times 2 is going to be 45 liters of H2O. Number 3, the combustion of a certain wax can be represented by the following balanced equation. If 185 grams of wax burns, how many liters of oxygen gas were used up? Assume the conditions in the lab were that. So we're given grams, we need to find liters. So the first step is for grams to liters, it's Pivner and then Gastoik. But from liters to grams, it's Gastoik. It's the table. I don't know what you call it, the table, the Gastoik, and then Pivner. Yeah. So from grams to liters, we need to use Gastoik and then Pivner because well actually I don't think it matters too much which way you do it. But in this case, let's go from let's find out how many grams of O2 there were. So we have 185 grams of wax. Right, and then you can go to no, yeah. What am I saying? Yeah, you have to do this way. So yeah, you have to go from gas and then from 185 grams of C22H44, it's you want to get the moles of the O2 in the end. And then to get from grams to moles, you have to find the moles of C22H44. So it's grams of moles C22H44 has a molar mass of 308.572. Oh, it's getting hot in here. Okay, so C22 carbon is 12.011 times 22. H is 1.008 times 44. We add both these together, we get 308. Oh, okay. And then from moles to O2, where we have moles of moles of O2 to moles of C22H44. The moles, there are 33 moles. And then for C22H44 for wax, it's only gonna be 1. And so you multiply all this together, right? Times 33, you're gonna get 19.78 moles of O2. And then you have moles of O2, and you get to liters of O2, you're gonna be using Pivner. So Pivner, yeah, Pivner is gonna be 101. Pressure is 101. 25 degrees Celsius. PV is what you're trying to find. V is what you're trying to find, the liters. Equals N is 19.78. The arc constant is 8.314. Or is it 8 point, what's the arc constant? I don't know. Yeah, 8.314. And then the temperature is not 25 degrees Celsius. It's going to be 3298.15 Kelvin. Gosh. You plug and chug, V is going to be 480 liters of O2. So number 4, zinc metal reacts with hydrochloric acid to produce hydrogen gas. How many liters of hydrogen can be produced at STP if 13.5 grams of zinc are reacted with excess HCl? So first, we see that is that STP. So whenever they give you STP, we can actually skip the whole like Pivner and gas stoic entirely and just do the whole like stoichiometry. Um, so we have to go from grams of zinc to liters of hydrogen. So we have 13.5. This is what we start out with, grams of zinc. When you get to the moles of zinc, so grams of moles. Oh wait, hold on. We need to end up with liters of H2. So grams per moles. Zinc has a molar mass of what is it? Oh, 65.38. And then yeah. And then we can use the mole ratio. Moles of Zn to moles of what do we need? HCl. So the moles of HCl is 2, Zn is 1. And then hold on, it's gonna be liters of hydrogen, not bad. It's gonna be 1, 1. And then from moles of H2, 1 mole of H2, this is where STP comes in. There's 22.4 liters in 1 mole. 22.4 liters. This one gonna give you, if you plug all this in, it's gonna give you 4.6 liters of H2. Okay, number 5, last one. If 210 grams of hydrogen gas reacts with atmosphere and of excess nitrogen, how many liters of NH3 can be produced? Assume conditions are STP. Thank the Lord at STP, because now we can skip some of the stuff. We can skip Pivner. So we start out with what we have, 210 grams of H2. Oh wait, we need to write the chemical formula. So hydrogen gas H2 reacts with N2 to produce NH3. Balance this. Okay. And so 210 H2 grams, you go from grams to moles. 1 mole has 2.016 grams of hydrogen because it's diatomic. And then we use the mole ratio. Moles we need to find NH3. So there's 2 moles of NH3, there's 3 moles of H2, and then last but not least, STP. 1 mole of NH3 gives you 22.4 liters of NH3. 1,600 liters of NH3. Okay, that's it. Later. Time to eat lunch.